For over a decade, we've heard promises about electric cars that can go 1,000 miles on a single charge, but clearly, no EV maker has delivered on that yet. It's not because EVs haven't made big strides in technology, though. The real reason is that the industry as a whole still hasn't cracked the code on breakthrough battery tech. Engineers and experts have been experimenting with all kinds of new battery chemistries and materials for years. But every time there's a glimmer of hope, a bunch of new challenges pop up with these next-gen batteries. Take solid-state batteries, for example. Toyota's betting big on them. They believe these could seriously shake up the leaderboard. These batteries promise insane energy density, with the potential to deliver at least 700 miles of range on a single charge. But in the real world, they come with major production and cost hurdles. That's why Toyota is still struggling to bring them to market. Now, here's where things get interesting. Tesla's battery partner, CATL, the world's largest battery manufacturer and the supplier for 70% of Tesla's EVs, has just shattered industry norms. They've managed to triple the energy density of regular LFP cells with their new lithium metal battery. Not only that, but it outperforms even the best solid-state batteries out there by 33%, and compared to Tesla's own 4680 cells, it's 84% more energy dense. If everything goes according to plan, Elon Musk and Tesla could be the first automaker to roll out EVs with this game-changing battery, thanks to their tight relationship with CATL. So how exactly does this new battery make 1,000 miles of range possible? Could this be the one that finally dethrones the 4680? Welcome to Tesla Car World. CATL is the world's top battery maker, and they've built a strong reputation for delivering real innovation. No hype, no empty promises. Whenever they announce a new battery, it usually hits the market within a year or two and ends up going mainstream. That's exactly why Elon Musk trusts them and keeps such a close relationship with CATL. At this point, CATL's basically explored every promising battery tech out there. They've got sodium-ion batteries, solid-state batteries, ultra-fast charging LFPs, and now lithium metal batteries, the most energy-dense ones we've seen so far. So, what is a lithium metal battery, and why does it matter? Unlike regular lithium-ion batteries that use graphite for the anode, lithium metal batteries use pure lithium metal. That one change is a big deal, because lithium metal has about 10 times the theoretical capacity of graphite. What that means is, you get way more energy packed into a battery that's smaller and lighter. And yeah, that means way more range for your EV. To break it down, most lithium iron phosphate batteries today have an energy density of around 165 watt-hours per kilogram. Tesla's 4680 has an energy density of 272 watt-hours per kilogram. Even Solid Power's advanced solid-state battery only has an energy density of 375 watt-hours per kilogram. CATL's lithium metal battery, meanwhile, has an energy density of over 500 watt-hours per kilogram, a 33% improvement over the best solid-state batteries and 3 times that of LFP batteries. This leap means unprecedented range and performance for electric vehicles. Put simply, if you take a Tesla Model Y or a BYD Seal and replace the current battery with this lithium metal battery, with a pack capacity of around 70 kilowatt-hours, you will easily get a range of around 600 miles without having to consider the increased weight of the vehicle. To achieve this breakthrough, CATL has discovered a major breakthrough for lithium metal batteries. Using a quantitative mapping method, this has taken them into previously uncharted territory, especially in electrolyte strategy and research, which CATL believes will have huge benefits for the entire global automotive industry. In addition, CATL is looking to upgrade the materials for the electrolyte in lithium metal batteries. The electrolyte is the part in the middle of a battery cell that allows ions between the cathode and anode to flow through and generate electricity. This is an essential part of any battery, and the rate of ion transfer, durability, and safety all depend on the electrolyte. Thanks to these innovations, CATL's current prototype already hits 483 charge cycles and delivers an energy density of over 500 watt-hours per kilogram. But let's be clear, this is still just a prototype and it's only going to get better from here. Now, 483 cycles isn't exactly impressive, it's actually on the low side. CATL fully acknowledges this. The biggest challenge with lithium metal batteries right now is cycle life, how many times the battery can be charged and discharged before its performance drops off. And yeah, it's going to take more time to solve that. But remember, this is CATL we're talking about. They don't do anything halfway. To speed up the process of improving cycle life, CATL developed a complete set of advanced analysis techniques to track how lithium and the components of the electrolyte evolve throughout the battery's lifespan. The key breakthrough came from analyzing electrolyte behavior. CATL discovered that the main reason these batteries fail is due to the constant consumption of electrolyte salts, especially lithium bis fluorosulfonyl imide, with about 71% of it breaking down by the time the battery stops working. Using their analysis tools, they were able to clearly map out how lithium and electrolyte components change over time. That insight led them to create a new electrolyte formula with a lower molecular weight, higher salt concentration, better ion conductivity, and lower viscosity, all without increasing the battery's total mass. The result? A prototype with double the cycle life of earlier versions. And CATL isn't stopping there. They're now using AI to fine-tune the electrolyte formula, speeding up the path to full-scale commercialization. If they manage to double the cycle life once or twice more, lithium metal batteries could finally go head-to-head with today's lithium-ion batteries, but with way better energy density. And for Tesla, this could be a real game-changer. Tesla's mission has always been to accelerate the world's shift to sustainable energy through high-performance, affordable EVs, and lithium metal batteries fit that mission perfectly. Like we mentioned earlier, just imagine putting one of these batteries in a Tesla Model Y with a 70 kilowatt-hour battery pack. You're looking at 600 miles of range easily because the pack would hold 3 times the energy of a typical LFP pack. And if Tesla decides to go with something bigger, say a 95 kilowatt-hour battery pack, 1,000 miles of range suddenly doesn't sound unrealistic at all. That kind of energy density also means smaller, lighter battery packs, which help cut production costs and open the door for more affordable EV models. And honestly, this makes us think of the next-gen Tesla Roadster, because, as CATL puts it, high-energy density batteries don't just benefit daily drivers. They also unlock serious potential for electric supercars, heavy-duty trucks, and even aircraft. By integrating this battery within the next 2 or 3 years, Tesla could pull way ahead in the EV race, offering vehicles with unmatched range and efficiency. But it isn't just about Tesla. CATL's lithium metal battery has the potential to reshape the entire EV industry. By 2035, when many regions are expected to ban internal combustion engine vehicles, high-density batteries like this could become the new standard. A 500 watt-hour per kilogram battery could literally double the range of today's electric vehicles, making EVs the obvious default choice for everyone. And it doesn't stop with cars. This tech could also power electric aviation and grid-scale energy storage, giving a major boost to global decarbonization efforts. CATL has actually been working on lithium metal batteries for over a decade. Founded in 2011, they quickly became a trusted supplier to Tesla, BYD, Volkswagen, and other major automakers. What sets them apart is their ability to take breakthrough battery tech from the lab to full-scale production, faster and more reliably than anyone else. While CATL hasn't publicly said exactly when they started developing lithium metal batteries, industry reports suggest they've been heavily focused on it since around 2015. Tackling challenges like short cycle life and safety concerns head-on. And with over 30% of the global EV battery market, CATL has the resources and scale to turn R&D into mass-produced, dependable products. Their partnerships with Tesla, BYD, and other top car makers speak volumes about how much trust the industry has in their technology. And CATL isn't just betting on high-performance batteries. They also believe their sodium-ion batteries will spark a whole new wave of affordable EVs, since sodium-ion is widely seen as the cheapest battery chemistry in the world. In fact, CATL became the first automotive battery manufacturer to launch sodium-ion batteries in 2021. But due to limited performance parameters, the commercialization of the first generation of sodium batteries has not been widely expanded. But now, CATL's Naxtra battery has broken the performance boundary of the material itself, achieving mass production of sodium-ion batteries for the first time. Specifically, CATL's Naxtra EV battery achieves an energy density of 175 watt-hours per kilogram, the highest among sodium-ion batteries worldwide and comparable to LFP batteries. This enables the Naxtra battery to help EVs achieve a range of 500 kilometers and can achieve more than 10,000 cycles, significantly reducing maintenance costs. You may not know, but achieving an energy density of 175 watt-hours per kilogram for a sodium battery is extremely difficult. Why? In fact, the energy density of sodium batteries is usually quite low, only around 130 to 150 watt-hours per kilogram. The reason is that sodium ions are larger in size than lithium ions. This means that more space is needed to accommodate sodium ions when the battery is operating. As a result, the cells in sodium-ion batteries need to be larger or have more space to accommodate the required amount of ions, resulting in a lower energy density. On the other hand, sodium is heavier than lithium. This means that sodium-ion batteries will be heavier in mass compared to lithium-ion batteries of the same capacity. This makes the energy density by weight watt-hours per kilogram of sodium-ion batteries lower than lithium-ion. That is why sodium batteries have consumed years of research by millions of researchers around the world just to find a way to make it have a higher energy density, and CATL is proof that they have found a practical solution. Of course, we have to admit that the energy density of 175 watt-hours per kilogram is not an impressive number. Compared to the 4680 battery with a density of 272 watt-hours per kilogram, the Naxtra battery is still quite far away. CATL's goal is that sodium batteries can soon reach 200 watt-hours per kilogram, but at the moment, it seems that this will not happen anytime soon. Despite having an average energy density on the contrary, the Naxtra battery's charging time can blow any battery away, with just 5 minutes of charging giving you 310 miles of range. For any battery technology, the key factor in determining whether charging is fast or slow always lies in the movement of ions between the electrodes during charging and discharging. In Naxtra batteries, sodium ions move between the anode and cathode through the electrolyte. One of the reasons why these batteries have high charging and discharging speeds is the favorable ionic conductivity of sodium ions in the electrolyte. Sodium ions carry a single positive charge, similar to lithium, but their larger ionic radius allows them to move relatively easily through certain electrolytes, especially those optimized for sodium-ion batteries. In liquid electrolytes, sodium can exhibit rapid diffusion, facilitating faster ion transport during both charging and discharging processes. This speed means it's capable of fully charging a Tesla Model Y in just 5 minutes. Oh my God, that's clearly close to the experience of refueling a gasoline car. Customers also experience reduced range anxiety and increased confidence when using electric vehicles. In addition to the ultra-fast charging potential for EVs, similar to gas refueling, the ultra-fast charging advantage of Naxtra batteries also benefits power tools or heavy-duty industrial equipment. The high discharge rate ensures that the Naxtra battery can deliver the necessary power within a short time frame, supporting demanding workloads. This makes sodium-ion batteries an attractive option for high-power applications that require instant energy delivery. As we mentioned earlier, Naxtra batteries not only have a cost advantage, but they can also be considered one of the safest types of batteries for electric vehicles. This is evidenced by CATL sharing results from a series of rigorous stress tests, including drilling into a cell and even cutting it in half, without any thermal events occurring. This is largely thanks to the sodium-based chemistry inside the battery. According to CATL, the Naxtra battery can operate across a wide temperature range from -40 degrees Celsius to over 70 degrees Celsius, redefining the extreme temperature limits of batteries. The Naxtra battery retains 90% of its usable capacity at -40 degrees Celsius. Even at an extremely low state of charge, it shows no significant power degradation at -40 degrees Celsius. Compared to lithium batteries, sodium-ion batteries inherently have better resistance to overheating. reducing the risk of fire or explosion under thermal stress. Studies show that sodium-ion batteries are less flammable due to their more stable chemical structure and are less likely to explode in the event of a short circuit, offering a higher level of safety in technical failure scenarios. Additionally, sodium is a non-toxic material, minimizing health risks in the event of battery breakage or damage. You no longer have to worry about terrifying EV fires with thick plumes of smoke from lithium batteries. One standout advantage of sodium-ion batteries that we particularly value is their ability to maintain stable performance at low temperatures. Many have demonstrated that they can still charge from 5% to 80% in just 15 minutes, even at -10 degrees Celsius. This makes sodium-ion batteries an ideal choice for regions with harsh winters or cold environments, where EV performance degradation during winter is one of the main reasons many consumers are still hesitant to adopt electric vehicles. Therefore, Naxtra batteries may shift public perception and spark a revolution by offering minimal capacity degradation at low temperatures and functioning efficiently in extreme cold down to -40 degrees Celsius. The so-called winter range anxiety for EVs might soon fade away. Although CATL has not disclosed the exact cost of each battery cell produced, if sodium-ion batteries are manufactured at scale, they could be 20% to 30% cheaper than LFP batteries, mainly due to the abundant supply of sodium and its low extraction and refinement costs. Sodium-ion batteries can also use aluminum for the anode current collector instead of copper, which is used in lithium-ion batteries, further reducing costs and supply chain risks. Replacing all lithium in lithium-ion batteries with sodium could lead to up to a 30% reduction in cost. What does that mean? That 30% is a huge advantage. In many cases, just a few percentage points in price difference can determine the survival of an industry. As we mentioned earlier, sodium is the primary component of Naxtra batteries, easily found in many places and much cheaper than lithium. Sodium is the sixth most abundant element in the Earth's crust, while lithium is relatively rare and mainly extracted from mineral deposits and brine, making its mining and transportation more expensive. Lithium mines are concentrated in specific regions such as Chile and Australia, which causes price volatility. But that's not all. Lithium-ion batteries often require rare materials, like cobalt, nickel, and lithium, which drive up production costs. In contrast, sodium-ion batteries primarily use sodium, a common and inexpensive metal. Some sodium-ion battery manufacturers also use cathode materials, like manganese or iron instead of cobalt, further reducing costs. According to a 2022 report by ID TechX, the production cost of sodium-ion batteries could drop to around $100 per kilowatt-hour, while current lithium-ion battery costs are around $140 to $150 per kilowatt-hour. This shows that sodium-ion technology could be 30 to 40% cheaper than lithium-ion. The production of sodium-ion batteries is expected to begin in June, starting with small starter batteries for heavy-duty trucks under the Naxtra brand. These new batteries are expected to offer a significant advantage for vehicle startups in cold weather. Mass production of larger batteries for electric vehicles and hybrids is expected to begin in December this year. Tesla adopting sodium-ion battery technology, such as the Naxtra battery, would be a logical and strategic move to reduce electric vehicle production costs, especially considering Tesla's long-term partnership with CATL. This technology could help Tesla achieve its goal of producing the Model 2 at a $25,000 price point, while reducing reliance on more expensive battery types like lithium-ion. However, tariffs and other trade-related factors will need to be taken into account to ensure the feasibility of applying sodium-ion batteries in the U.S. market.